Syar binti Jamsari. I'm from AS123B.
Hi and Assalamualaikum. My name is Nur Farisha Hanis binti Hanif and I am from AS124TB.
Hi, Assalamualaikum. My name is Muhammad Shaikal bin Muhammad Faiz and I'm from AS1243B.
Hello, my name is Muhammad Akini bin Azman and I'm from class AS1243B.
A technique known as another name for volumetric analysis is a quantitative analytical method that finds a substance concentration in a sample. The basis of this technique is the measurement of the volume of a solution titrant with a known concentration needed to fully react with the analytical substance under investigation. Chemistry uses volumetric analysis a lot, especially in areas like quality control, pharmaceutical, and environmental science. Titration is a particular kind of volumetric analysis in which a chemical solution is gradually mixed with a solution of a known concentration called a titrate until the reaction is finished. The similarity point is the point at which the reaction reaches a balance. An indicator or specialized tool like a pH meter are frequently used to find this point.
Let's move on to the theory behind titration in detergent industry. In detergent industry, the titration process is commonly being used to determine the amount of acidic and alkaline substance present in detergent sample. The theory involves neutralizing the sample with a standardized solution of an acid or a base. This helps in quantifying the concentration of the active cleaning agents or adjusting the pH to optimal levels for performance. Chemical reaction in detergent depends on which type of the detergent or surfactant being analyzed and also the titrant used. We will go through the example of anionic detergent titration. The detergent that being used is sodium dodecyl sulfate, which is an ionic detergent. It reacts with cationic titrant, which is tetramethyl ammonium bromide, leading to formation of the dodecyl alcohol along with the centimethyl ammonium ion and bromide ion. As for the equivalence point, it can be determined by using pH indicator method because a lot of detergent titration involve the change in pH. The diagram shows where the equivalence points in the titration reach when the pH is equal to 7. It happens when the titrate added is completely neutralize the analyte solution that include a few drops of the indicator. For example of the indicator are phenolphthalein, bromothymol blue, and methyl orange. We will go through the example of stoichiometry calculation for the reaction between lithium hydroxide and carbon dioxide in this section. First step is balance the equation. After balancing, we get 2 mole of lithium hydroxide plus 1 mole of carbon dioxide and produce 1 mole of lithium carbonate plus 1 mole of water. After that, we need to convert the mass to moles. After converting, we get 41.8 mole lithium hydroxide. Then, perform mole ratio and then calculate the unknown carbon dioxide moles needed, which we get 20.9 mole. The last step is convert the moles of carbon dioxide to mass and the final answer is 9.2 multiplied by 10 power of 2 gram carbon dioxide.
Producing detergent involves the careful formulation of ingredients to achieve desired cleaning properties, and titration can play a role in determining the concentration of key components. Here is a simplified guide to producing detergent using titration application, focusing on the determination of a key ingredient, such as the concentration of a surfactant. Material and apparatus. First, surfactant. Surfactant is a primary cleaning agent in a detergent, for example, sodium lauryl sulfate. Second is a titrant solution. Titrant solution is a standardized solution of an acid or a base, depending on the nature of the surfactant. Third is indicator. Indicator is an appropriate indicator for the titration. And lastly is burette, pipette, and conical flask. Procedure of titration in detergent industry. First, measure the detergent sample based on the expected concentration and titration method sensitivity. Second, prepare a non-concentration titrant solution based on the surfactant's nature. Next, add indicator drops to detergent sample, indicating the endpoint of the titration. And Then, calibrate the burette with the titrate solution for accurate volume measurements. Next, transfer the detergent sample to a conical flask and position the burette filled with the titrate above the flask. Next, record the initial volume reading on the burette, and then gradually add the titrate solution to the detergent sample, stirring continuously. And then, record the final volume reading when the color change is observed. Next, calculate the surfactant concentration in the detergent sample using the volume of titrate in known concentration. Next, perform the titration at least 3 times for accuracy and precision. And lastly, adjust the detergent formulation based on the determined surfactant concentration.
Titration is a method that determines the concentration of substance in a solution by measuring the volume of non-reactant needed for a complete reaction. The reaction involves adding a known concentration titrant to an unknown concentration analyte, with the endpoint usually indicated by a color change or electrical measurement. Common titration includes acid-base titration, redox titration, precipitation titration, and complexometric titration. The unknown analyte concentration can be calculated using stoichiometry and titrant volume, requiring accurate experimental technique for accurate result. First, we need to select an acid-base or redox reaction and find reagent with known concentration to act as the analyte and titrant, and then prepare our solution by ensuring the concentration of titrate and analyte are accurate and standardizing any self-made solutions. Choose an indicator that changes the color near the titration, reaction equivalence point, and calibrate your equipment, including burette, pipettes, and analytical balance for accurate measurement. The analyte solution is added to an aluminium flask, recorded the volume, and then a few drops of indicator solution are added. Titrate the solution by adding the titrant from the burette to the swirling analyte solution until the indicator changes color, and then record the reading and repeat at least 2 more trials. The unknown concentration can be determined by calculating the titrant volume and its concentration and the stoichiometry of the chemical reaction.
Uses. Detergent are adaptable cleaning solutions that can be used in many different contexts. Their main job is to disintegrate and get rid of stains, grease, and dirt from surfaces. These are a few typical uses of detergent. First, cleaning of laundry. Laundry detergents are widely used to get rid of oil, dirt, and stains from clothes. They facilitate the dissolution and breakdown of these materials, making it possible to rinse them away during washing. For example, color safe detergent, stain remover detergent, sensitive skin detergent, and baby laundry detergent. Second, cleaning the dishes. Dishwashing detergents are designed to remove particles of food and grease from cookware, dish, and utensils. They improve and increase the effectiveness of the cleaning procedure. Third, items for personal care. Shampoo, body wash, and hand soaps are examples of personal care products that contain mild detergents. These detergents assist in mixing and washing away debris or oils from the skin and hair. For example, sodium lauryl sulfate uses in toothpaste. Next, healthcare cleaning environment. Detergents are used in hospitals and other healthcare facilities to clean and disinfect surface in order to maintain the cleanliness of the facilities and stop the spread of infection. To make sure that cleaning procedures are efficient in lowering the risk of infection, healthcare facilities may rely on particular protocols or utilize detergents disinfection combination. Next, healthcare cleaning environment. Detergents are used in hospitals and other healthcare facilities to clean and disinfect surface in order to maintain the cleanliness of the facilities and stop the spread of infection. To make sure that cleaning procedures are efficient in lowering the risk of infection, healthcare facilities may rely on particular protocols or utilize detergents disinfection combination. Lastly, industrial procedure. In industrial process, detergents are occasionally used to clean and degrease parts and components. In manufacturing and maintenance operation, this is typical.
Titration analysis accurately detects equivalent point, allowing concentration calculation. Careful experimental technique including volume measurements and standardization ensure reproducible results. The experiment underscored the significance of titration as a fundamental analytical technique in chemistry, highlighting its reliability, accuracy, and versatility in various scientific disciplines and industries.